Okay, hello everyone, and welcome to MA304 Machine Design. We're going to do this problem with just a set of gears traveling with a certain horsepower and RPM. Go ahead and pause the video here to write down this problem. I'm just going to go ahead and jump right into it. Alrighty then, so the first thing you want to do with these two gears is create free body diagrams for each one of them. So if we look at the top gear, or the bottom gear, sorry, you'll have a reaction force of WT and the radial reaction force of WR, so tangential and R. And then here at the pinion, you're also going to have FA2X. This is gear A. Wait, make sure I'm using the correct nomenclature here when I'm talking to you about this. Ready? Right there. Okay. Yes, this is the bottom gear. Gear A. We're calling this A just because that's the bearing location. This is gear 2. If you want to look at it like that. Alrighty then. And the reason we're starting with this gear is because it's the one with the torque actually applied to it. So we have Tn applied. Okay, and then we have FA2Y. And that is X. Y. Okay. Now for gear 3, go ahead and draw it like this, and then we're going to have the reaction FB3X, FY, B3, and then we've got the force from 2 to 3 radial, and the force from 2 to 3 tangential. Alrighty then. So these are basically the reaction forces. These are the forces actually being applied by this gear spinning around and spinning this gear. So you can imagine if this gear is down right here, it's spinning at this rate, so it's applying a force right there and a force inward. Most of the time, the radial forces you almost ignore, but you want to draw them anyway just in case you ever have a special system. But in a good gear system, there shouldn't really be much of a radial force in this position. Okay, so then, finding what the torque in is, you use the equation of H, which is horsepower, the power, all over 2 pi n. Now this equation is a simple equation, but you really have to watch the units that you're using. So we have 150 horsepower going in, but we have to convert that to make sure it's in all the correct units into a force, actually a foot per minute force or velocity. So we know that WT is equal to 33,000 times horsepower over V. So we're going to go ahead and make that conversion right now. We've got horsepower, we've got 33,000 foot pounds per minute per horsepower. And I'm going to go ahead and erase this other part here because it's in my way. And then you multiply that, you have foot pounds per minute, but you need it in inches. So we multiply 12 inches per foot. So now that we have inch pounds per minute per horsepower, and then you go 2 pi times 1800 revolutions per minute. Okay, and this should leave you everything but foot pounds. So this is where a place where you really want to watch your units, because the horsepowers will cancel, the minutes will cancel, the feet will, the feet will cancel, and then you end up with inch pounds for your torque. So if you go ahead and solve this out, you'll find out that the torque in is equal to 5,252 inch pounds. Okay, so that's useful. Now, we need to find out what the diameters of each one of these gears are from the pitch and number of teeth. So the diameter of 2 is equal to number of teeth over pitch, and 2. Pitch is the same for both gears. is 18 all over 3 inches, so minus 1, which is equal to 6 inches. So then WT is equal to Tn all over D2 over 2, which is the radius, so basically the angle arm, because that's how far the force has to cross. So then this is equal to 52 inch-pounds, lb, all over 6 inches divided by 2, which is equal to 3 inches. So this divided by 3, which is equal to 1751 pounds, is the WT being created on this gear, basically, from the torque. So then, if you want to complete this, you go to WR, and if you're applying WT, tangent of 20 degrees, because all these gears are acting at a pressure angle of 20 degrees, then you go ahead. This is actually a little bit odd. I wonder why my professor did it like this. Alright. Well, anyway, this is going to equal 637 pounds. Alrighty, that should get us there. Radial, yes, and the radial is less than the tangential happening on the gear, so that should be pretty good. Alrighty, yes, okay. So now, moving on to the forces on the second gear, basically. Gear 3, we have FA2X is equal to WT, because they're equal and opposite on the gears, which is equal to 1751 lb. And then FA2Y is equal to WR, which is equal to 637 lb, which is, again, equal and opposite. So then FA2, if you're looking at this, FA2 will be something right in here, some in-betweener at as a right triangle, and you can see that F23 and F23R are the two sides of the right triangle. So you can just use Pythagoras' theorem to solve for this. Alrighty then, so FA2 is equal to the square root 1751 squared plus 637 squared. So then FA2 is going to equal 1863 lb. Alrighty. So then we've got this force acting up on this gear, basically acting right there on the pinion, because it's acting down here. It's going to be acting through the pin or through the shaft as well. So then all you have to do really is say, okay, well, on our gear, we've got a bearing right here and a bearing right here. Both of them are equidistant from the from the gear, where this force is acting up on an angle, and since the gears are circular, it doesn't matter what angle this force is acting at, because it's going to act on these the same way. You don't need to have an X and Y on it in this problem, so it's no big deal. So then FA plus F, or equal to FB, because they're equally spaced, it's going to be 1863 over 2, because they're sharing, each bearing is sharing half of the load, which is equal to 932 pounds. Alrighty then, for gear 3, okay, then F23T is going to equal WT, like I said before, which is equal to 1751. W23R is equal to W32R, which is equal to 637. Let's go through here and label all the stuff again. So then FB3X is equal to F23 tangential, again because it's circular gears and the force is identical. Or you can call these some of the forces equations, it doesn't really matter. Equal to 1751 lb, and then FB3Y is equal to F23R, which is equal to 637 lb. So then FB2 is equal to FA2, which is equal to 1863 lb. And again, since the two bearings are equidistant from the center of the gear on gear 3, you go ahead and split this in half, and V is equal to 1863 over 2 is equal to 932 pounds. So pretty darn easy.